Now we're going to look at inverse of sine, cosine, and tangents. What does it mean, inverse? So think about when we did inverse functions in Math 126, or whether you had it with me or someone else. And what an inverse function does, it undoes what the function does. So here, like we're taking a trig value of an angle, it'll produce, like in a right triangle, ratio of sides. In this, we take the inverse trig of that ratio of sides, it produces an angle. So that's one thing I want you to know, is that inverse, I'm going to write this here. It's kind of alluded to there, but inverse trig functions produce angles. Okay, I could have typed that, but I wrote it to make the point. So, for example, if we said sine of pi over 6 is 1/2, we all know that, we memorize that, right? Then sine inverse of 1/2 would give us pi over 6. And cosine of pi is -1. That means cosine inverse of -1 is that angle pi. And tangent of pi over 4 is 1. That means tangent inverse of 1 is pi over 4. So you may be saying to yourself, or saying to me, to the screen, well, wait a second. I know that sine does this. It's a periodic function. So how do we know which one we're talking about? Well, we have to limit our domain for the sine. So we cut off sine at pi over 2 negative and pi over 2 positive. Then we pass that horizontal line test. So we limit the domain like we would have done for an x squared function. We'll limit the domain. And notice that that captures all those values in between, as we see here in this graph. It captures all the values that sine will produce from -1 to 1. Likewise, with cosine, cosine does this. So if we want to get just one slice of everything that it's going to produce from -1 to 1, we go from 0 to pi. That's what we see here. So we limit the domain of the function, and that's why sine inverse of 1/2 produces only pi over 6. We don't have to worry about something, right there, or here, or here, or here, for that matter. We're just worried about it being right about there. Okay, so that's what this is saying here. This graph is sine function on a restricted domain of -pi over 2 to pi over 2, and cosine function on the restricted domain of 0 to pi. And then our tangent, we know tangent it's also periodic. So it goes -pi over 2, pi over 2, 3 pi over 2, and so on. So it does, let me get my asymptotes. We know it repeats itself, periodic. We just take one of those, and that's what we've done here. Take it from -pi over 2 to pi over 2. The difference being that we do not include those endpoints because it's not defined at the endpoints. So let me just go through these. So in these restricted domains, we can define inverse trig functions the following way. Inverse sine function, y equals sine inverse of x, means x equals sine of y. So y is the result from, all right, so y is the angle. Sine of the angle gives you x. Sine inverse of that x value gives you the angle. So y equals sine inverse of x has the domain of -1 to 1. Those are the values that we could plug into it, and a range of -pi over 2 to pi over 2. So what I want to stress is this was the output. This was the output of sine and input of sine, output of sine. So for our inverse function, -1 to 1 is the domain, and its output would be the range of sine. Likewise, for inverse cosine function, y equals cosine inverse of x, means x equals cosine of y. The inverse cosine function is sometimes called the arc cosine. Oh, I didn't read that. Yeah, the arc sine, arc cosine, arc tangent. That might actually be what's in your calculator too. think that's what's on my T84. Y equals cosine inverse of x has the domain of -1 to 1 and the range, though, of 0 to pi, as we discussed above in the diagram. Inverse tangent function, y equals tangent inverse of x, means x equals tangent of y. Inverse tangent function, sometimes called the arctangent function, and noted arctan x. So y equals tangent inverse of x has a domain of -infinity to infinity, meaning, so notice that in our tangent it produces -infinity to infinity, so its inverse function is -infinity to infinity, and its range is -pi/2 to pi/2, but with parentheses there, as it doesn't include them. So I included this graph here. This is showing the darker blue is our sine, and then this lighter blue or teal, whatever color you might call that, this is our sine inverse. It's interesting to see them graphed on the same graph. But as we stated earlier, your sine is going to look something like that. And I'm going to tell you now, your inverse sine will look something like, let me see if I can recreate it, like that. Just notice how the curve goes. Okay. Likewise with your cosine and your cosine inverse. So while your cosine that we look at does this, your cosine inverse, it'll produce values from 0 to pi. Those are the y values. And then call this -1, call this 1. So it's going to go up like that. Because cosine of 0 is 1, cosine of pi is -1. So cosine inverse of pi is, cosine inverse of 1 is pi. I keep saying it wrong. I apologize. Cosine inverse of 1 is 0. Cosine inverse of pi is, cosine inverse of 1 is pi. Boy, I should move on before I keep saying things wrong. And then in our tangent, as I showed you a second ago, we get that kind of a graph for tangent. So its inverse function would look something more like this. Okay. Let's see how we can use this. So given that sine of 5pi/12 is approximately 0.96593, write the relation involving the inverse sine function. So sine inverse of 0.96593 is approximately 5pi/12.